Hi, I am Arib. You are watching my YouTube channel. Electrical power grid station and working. Definition: an electrical power grid is an interconnected network that delivers the generated power to the consumers. It is sometimes also called as an electrical power system. A power grid consists of generating stations, power plants, transmission system and distribution system. Power generating stations are located at feasible places according to the availability of the fuel, the dam site or an efficient location for renewable sources. Hence, they are often located quite away from the populated areas. This is very practical since the transmission of electrical power over longer distances is a lot much economical than the relative transmission of any other fuel. Also, a hydroelectric plant must be located according to an appropriate dam site, or a wind power plant may be located offshore to harvest additional energy from the wind. Thus, a long-distance transmission system is needed to transmit the generated electricity to the populated areas. And a distribution system is needed to distribute the power to every consumer at appropriate voltages. What is a grid station? An electrical grid station, the combination of different electrical equipment to control the electrical power and its supply. It contains transformers, cables, control systems, and many other types of equipment. The main task of a grid station is to transfer the electricity to very far distances where the users are located. They also interconnect all the power plants of a country so that if one power plant fails, you still receive the electricity uninterrupted. How does a power grid work? A power grid can be divided into three stages: power generation, transmission, and distribution. Each of these stages is explained in details below. Types of grid stations. There are mainly three types of electrical grid stations. Microgrid station. A microgrid covers a small area or local community. It takes electricity from the main grid. But in case of electricity failure, it goes to the island mode. In this mode, it can run on the electricity produced from local sources like solar or wind. National grid station. National grid covers large regions across a country. This type of grid station connects microgrids with national grids or grids over a continent. Therefore, their power carrying capacity is huge. In Europe, a national grid transmits 660 gigawatts of electricity. The electricity transmission is done on high voltage alternate current (HVAC) among national grids at longer distances. These grids have a usual voltage of 500,000 volts or more. Compare this with your household voltage, that is 110 by 220 volts. Super grid station. A super grid station is also known as a mega grid station. Unlike regional grids, the super grids transmit the power in high voltage direct current (HVDC). Due to this, a very small amount of power is lost on long distances. Central Asia South Asia (CASA 1000) is the type of mega grid that connects to Asian blocks. Power generation. Electricity is generated in power plants which are often located far away from the populated areas. There are various types of power generating stations such as thermal, nuclear, hydro, solar, wind, etc. A power plant may consist two or more three-phase alternators which are operated in parallel. Electricity is generated in power plants at voltages ranging from 11 kV up to 25 kV. Generation voltage cannot be much higher due to technical limitations. Transmission. For the transmission of power over longer distances, the generated voltages are stepped up to a much higher level. A step-up transformer is used for this purpose. which increases the voltage level with the corresponding decrease in the current. Stepping up the voltage is necessary to increase the transmission efficiency by reducing I/R losses in the transmission lines. Higher the transmission voltage means lesser the current and hence lesser the I/R loss. Transmission voltages are generally to 20 kV or greater up to 765 kV. Transmission lines are often seen running over tall towers at the outskirts of a city. Most commonly, three-phase AC power at very high voltage is used for the power transmission. But due to the advancements in power electronics, HVDC, high voltage DC, has proved many advantages for longer distance transmission. So, HVDC transmission systems are being employed for very longer distance power transmission. AC power is converted into HVDC at a converter station for the transmission, and then it is converted back into AC at the other end. Also, HVDC link is the only option today for interconnecting grids with different frequencies. Distribution power from the transmission system is then stepped down to a considerably lower voltage, say 33 to 66 kV, using a step-down transformer in a primary step-down substation. The power is then carried to distribution substations or directly to very large industrial consumers. At distribution substations, the power is further stepped down, say at 11 kV. Power distribution is carried out using overhead or underground distribution lines, which are usually interconnected in a ring or mesh network types. Distribution transformers are used to lower the voltage further to the utilization voltage, 120 volts or 230 volts, and supply several consumers using the secondary distribution lines. This is, however, a general overview of an electric power grid. But, practically, a power grid is much more complex. The voltage levels for transmission and distribution vary widely. History of electrical grid stations. Grid stations were first developed in the 1880s. New York City had a microgrid that supplied electricity in direct current form. But it faced huge power losses when the electricity was transmitted to long distances. After the invention of alternating current by Nikola Tesla, power transmission at a long distance was achieved with low losses. It is because the alternating current is easy in increasing and decreasing voltage levels by the use of transformers. British electrical engineer Charles Mays built a central electric grid in 1901. It was located in the city of Newcastle, England, and was named Neptune Bank Power Station. The first national grid was developed in 1938 by England's Central Electricity Board. It carried electricity at 132 kV and 50 Hz frequency. The USA and France followed England in electricity production and transmission by the use of grid stations in the 1920s. Since then, huge progress has been done to modernize electricity grids with minimum waste and environment-friendly processes.